2012 question 15. Which of the following concerning an iodine atom with a mass number of 131? So here, before I continue with the question, this way of presenting the atomic symbol on the top here, this would mean that this is the mass number. And as we know, mass number is equal to the number of protons plus the number of neutrons. And here at the bottom, this would be the atomic number. So here, of course, we don't see any number here. So, but we would know that this is the atomic number here. So, which of the following concerning an iodine atom with a mass number of 131 and a xenon atom with also the same mass number of 131 is or are correct? So, we're given three options. So, here for convenience sake, I have taken out the periodic table, which you can find usually at the end or in the beginning. On your textbook, is in the beginning. In the past papers, you'll find it at the end of book one, paper 1B. So here, iodine atom here. Now, it's a bit different from how the question is presented. In this periodic table here, this one at the top is the atomic number. So maybe I'll use a different color. This one at the top here is the atomic number. And as we know, the atomic number is also the same as the proton number. So here, the proton number of iodine is 53, whereas for xenon is 54. So obviously, option 1 is wrong because they're not having the same number of protons. Option 2, they have different number of neutrons. Is that correct? Yep, that is true. Because we could see that for both of them, for iodine, for example, it's having, let me represent it this way. The mass number is 131. The proton number is 53. So the neutron number would be simply 131 minus 53, which you will get 78. And how about for the other xenon? How about that one? Yep, you could do the same thing. For xenon here, you can again write down the mass number, and this time it has a proton number of 54, atomic number of 54. So the number of neutrons for this would be 131 minus 54, which is 77. So yes, option 2 is correct. They have different number of neutrons. And anyway, since you know that option 1 is wrong, definitely option 2 would be correct no matter what. But for the sake of this video, we'll continue on by checking option 2. Now option 3, it says they have different number of outermost shell electrons. Yes, that is also true. As we know, the atomic numbers here, if they have a different atomic number, they have different proton numbers, and usually it is the case that it will also be equal to the electron number here, to the number of electrons. Now, it may not be the case all the time because if there are presence of ions, then that's when the electron numbers may change. But generally speaking, if there aren't any ions present, then we could follow this rule of thumb, atomic number equal to the proton number, or which is equal to the electron number. So here, option 3 is also correct. So our answer is D.